The last three problems on the algebra review test have to do with factoring, quadratics. So here's one of them. Factor the quadratic expression, let me make this a little bigger, x squared plus 14x plus 24. Now, when it says factor the quadratic expression, now you know what you're looking for then. What you're going to do is you're going to turn this expression, x squared plus 14x plus 24, that big quadratic expression, you're going to turn that into a product of two small factors. Okay, and that's it. So remind us, how do we do that? If I want to turn this quadratic into a product of two small things, Tim, what do we do?
Figure out what first two factors of 24 load out onto 14.
Perfect. Exactly. Good. Okay. So, and those are the magic numbers we're looking for. We know that all we're doing here to go from here over to here is unfoiling, so to speak, right? We want to know what two factors would we have to FOIL together to get this. Now, first times first has to give us x squared, so we know that those are both x's immediately. But what we're looking for are those magic numbers, right? We want to know what goes there and what goes there. So what are the two numbers that multiply to 24 and add to 14? 12 and 2, sure. So we're going to get x plus 12 times x plus 2. And that's it. That's where we stop. If all we're trying to do is factor it, that's factor. So let's put that in. Let's put that into Moodle. Okay, so on page, it'd be 13. Okay, so then we just do this, right? We're just going to put in parentheses x plus 2 times x plus 12. It doesn't matter what order. The 2's or the 12, doesn't matter which one goes first, but that's it. Display of response, does that look like what we wanted?
Yes.
Yes, it does. And it is. Voila, we got it. Okay? Next. Okay, another one. Same deal, right? This just says factor. So we're going to take this quadratic expression, x squared minus x minus 20, and break it up into, and unfoil it, factor it into two small factors. So we just got to find the magic numbers again. Well, what are they? What are the two numbers that multiply to negative 20 and add to,
Negative x.
well, what's the number there?
1.
Negative
It's
1.
a 1.
To negative 1. Okay? So what are they? What two numbers multiply to negative 20 and add to negative 1?
1 and 20.
No, 1 and 20 wouldn't work because it wouldn't add to the right.
4 and negative 5.
Ah, okay. Okay, good.
Go.
Okay, now to help us out here, if that wasn't coming to us immediately, what we could say is we know that if they're going to multiply to a negative, one has to be negative and one has to be positive, and that helps us just a bit, right? And then we could just explore what are the factors of 20 and find the ones that work just right. Well, negative 5 and positive 4 work. They multiply to negative 20 and they add to negative 1. So we're done. Okay, and we can enter that in either order. It doesn't matter. Okay, last one. Now this one's a little different. I want you to now pay close attention to this because here's where people do most of the right work but still get the wrong answer sometimes. This one has different instructions associated with it. It says solve by factoring. Okay, so this is a little different. We're going to factor, but then we have to do something with those factors because what we're trying to do is solve an equation. We're not just factoring an expression. We're trying to find out when does this quadratic expression, x squared plus 13x plus 40 equals 0? Okay, so how did we do that? How did we do that? We took the equation x squared plus 13x plus 40 equals 0. And what was our strategy here? What did we do? Where did the factoring part come in? Okay. Yeah, remember what we said. Let's just briefly review. Why are we doing this? Well, it's very difficult for us to pick values of x that are somehow going to make this whole expression go to 0. That's very complicated. We could use trial and error maybe, but what if they weren't integers? What if they were some irrational numbers? We'd never get them, right? It's too hard. What we want to do instead is we want to break this apart into a product, right, of two factors, two small factors. And then we know, once we do that, we know that the product of these two factors can only equal 0 when either the first factor is 0 or the second factor is 0. And those will be easy equations to solve because these are small, not big, right? So the first step is to factor this thing. Okay, so when we unfoil it, we get our x's. What are the magic numbers going to be? What two numbers multiply to 40, add 13? Okay, 5 and 8. 5 and 8. There we go. So plus 5 plus 8. Now here's where people make mistakes, though. Okay, listen closely, because this is where most people, if things went south on them, this was it. They put those numbers in. Those are not the right answers. Those are not the solutions. Those are the magic numbers that we use to factor it, but that's it. We want to know what are the values of x that make this thing equal 0, right? So we got to go one step further. We've got to ask the question, what value of x is going to make that first factor equal 0? Because that would work. If the first factor was 0, 0 times some number equals 0. Well, what's that going to be? -5. Okay, so there's one of our answers. What about the other factor? If I set that equal to 0 and solve. So those are my two answers. Now we got to go back to the instructions though and make sure we're doing this correctly. It says express your answers in numerical order, separated by a comma. Okay, so in numerical order means, least to greatest. Which one would I enter first? -8. Aha. So I'd go -8, comma, -5. Okay, let's just see that happen. So if I go here, then I should be able to just go -8, comma, -5. And we got it. Okay? Make sense?
Yes.
We're done. That's it. All right.